Okay, Wildcat, so looking at 3, the Ol Switcharoo, inverses of linear and quadratic functions. The teacher works 1 and the student works 2 and 3. Warm up. I can solve each equation. All right, so to do that, we're going to use Desmos. So I'm going to graph the left side, so 2x minus 5 and y equals 97. I'm going to zoom out until I see that y equals 97 line. Ta-da! Point of intersection is the solution. It's the x value, so x equals 51. Okay. Go ahead and work 2 and 3 on your own. Let's take a look at the next page. Go ahead and mark out this page. All right, let's take a look at the next page. 3.1. The inverse of a function. Miguel is planning a trip to Turkey. Before he leaves, he wants to exchange his money to the Turkish lira, the official currency of Turkey. The exchange rate at the time of his trip is 4 lira per 1 US dollar. Complete the table of values to show the currency conversion for US dollars to Turkish lira. Okay, so that will be 4 times 100, which equals 400. And then this will be 4 times 250, which equals 1,000. And then this will be 4 times 400, which equals 1,600. 4 times 650, which I don't know at the top of the head, so we can just go to Desmos and do 4 times 650 is 2,600. Okay, and then 4 times 1,000 is 4,000. All right, go ahead and complete the table. All right, number 2, write an equation to represent the number of lira in terms of the number of US dollars. So that's y equals 4x, where x is the US currency and y is the Turkish currency. All right, let's take a look at the next. Suppose at the end of the trip, Miguel needs to convert any remaining lira to dollars. This situation is the inverse of the original situation. 3. What are the independent and dependent quantities of the inverse of the problem situation? How do these quantities compare to the quantities in question 1? The independent quantity is the amount of lira, and the dependent quantity is the amount in dollars. So basically, when you do the inverse, they switch. Okay? So this will be 100, 250, 400, 650, and 1,000. And then this will be 400, 1,000, 1,600, 2,600, and 4,000. All right, go ahead and complete the table. All right, number 5. Compare the tables in question 1 and 4. What do you notice? The columns are reversed. Or another way is switched. Okay. Number 6. Use a table to write an equation of the inverse of the problem situation. Does this equation represent a function? The inverse equation is y equals 1/4 x. This equation represents a function. All right, let's take a look at the next page. Recall that a function takes an input value, performs some operation on this value, and creates an output value. The inverse of function takes the output value, performs some operation on this value, and arrives back at the original function input value. In other words, an inverse of a function undoes the function. Worked example. Given a function f of x, you can determine the inverse algebraically by following these steps. Step 1. Replace the function f of x with another variable, generally y. Step 2. Switch x and y variables in this equation. Step 3. Solve for y. 7. Use the function notation to represent the number of lira f of x in terms of the number of US dollars x. So we have that f of x equals 4x. Then complete the steps shown in the worked example to represent the number of US dollars in terms of the number of lira. Compare the inverse equation you wrote in question 6. What do you notice? So first step, change f of x to y. Step 2, switch x and y. So x equals 4y. And then last step, we resolve for y. So we divide both sides by 4. This becomes 1. So you get 1 divided by 4x equals y. The inverse is the same equation that I wrote in question 6. All right, let's take a look at the next page. (3.2) Graphing inverses of function. In the previous activity, you wrote the inverse of a linear function using algebra. Let's consider how to show the inverse of a function using its graph. And table. For example, given a function f(x), you can determine the inverse of a function graphically by following these steps. Graph the function points from the table. So the function, we have x and f of x equals 4x, so that's 100, 400, so that point is 100, 400, which is right here. And then 250, 1,000, so 250, 1,000, right there. Okay, so that's this line right here. Okay, now let's graph the inverse function points from the table. So that's 400, 100, and 1,000, 250, which is about right here. Okay. Okay. Last step, graph the line y equals x. So if x is 0, y is 0, so 0, 0. If x is 200, y is 200. If x is 400, y is 400. If x is 800, y is 800. And if x is 1,000, y is 1,000. Okay, so this is y equals x. All right, go ahead and finish that up. All right, 2. Compare the image you created in the graph of the inverse. Go ahead and mark out A and B. And let's address the compare. The graph of the inverse of a function is a reflection of the function across the line y equals x. So you can see that these reflect over each other, or over the line y equals x. All right, let's take a look at the next page. All right, the teacher works 3a and the student works 3b and 3c. For each function, a given point on the graph of the function, determine the corresponding point on the graph of the inverse of the function. Given the point is a point on the graph of g of x, what is the corresponding point on the graph of the inverse? Real simple, you switch x and y, so that becomes 2, 3. 3. All right, go ahead and finish up A, and then complete B and C. Let's take a look at the next page. Exploring inverse of quadratics. You have determined inverses of linear functions by reflecting a function across the line y equals x. Consider the basic quadratic function f of x equals x squared. 1. Use the table to reflect f of x across the line y equals x to graph its inverse. So let's first graph x f of x. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. Okay. This is the y equals x line. So now all we do is switch these values. So that becomes 4, 1, 0, 1, 4. And this becomes negative 2, negative 1, 0, 1, 2. Okay, so let's go ahead and graph those points. So 4, negative 2, 1, negative 1, 0, 0, 1, 1, and 4, 2. Okay. Explain why the inverse is not a function based on the graph. So when I draw a vertical line, okay, it crosses once, twice. So the inverse is not a function because it does not pass the vertical line test. Okay, number 3. What is the domain and range of the function? What is the domain and range of the inverse of the function? So the function, f of x, is a function. The domain is all real numbers, and the range is y greater than or equal to 0. F inverse of x, so that's the inverse function. The domain is x greater than or equal to 0, and the range is all real numbers. Notice that the domain and range switched. All right. Number 3, what is the domain and range of the function? You can determine the equation, the inverse of the basic quadratic function, f of x equals x squared, the same way you determine the equation of the inverse of a linear function. Worked example, f of x equals x squared. Step 1, replace f of x equals y with y. Step 2, switch the x and y variables. Step 3, solve for y. So the equation of the inverse is y equals plus or minus square root of x. 4. Explain why the inverse is not a function based on its equation. The inverse is not a function because the square root of a number can have two variables, the positive square root and the negative square root. Let's take a look at the next page. You know that the inverse of f(x) equals x squared is not a function. However, you can restrict the domain of this function so that the inverse is also a function. To restrict the domain of a function means to define a new domain for the function that is a subset of the original domain. 5. Consider the graph of f of x equals x squared and the graph of the two equations that represent its inverse. A. Identify the restrictions of f of x equals x squared to produce the inverse equation y equals square root of x and y equals negative square root of x. Then state the domain and range of each inverse. Restriction, for y equals x squared. The domain is x greater than or equal to 0. The range is y greater than or equal to 0. For y equals square root of x, the domain is x greater than or equal to 0. The range is y greater than or equal to 0. Restrictions for y equals x squared. The domain is x less than or equal to 0. The range is y greater than or equal to 0. For y equals negative square root of x, the domain is x greater than or equal to 0. The range is y less than or equal to 0. B. How does the domain and range of the inverse relate to the restriction domain and range of the original function? The domain and range of the inverse are the reverse of the domain and range of the function. C. Do all the graphs represent functions? Explain your reasoning. All the above graphs represent a function. All right, go ahead and finish up your notes and have a wonderful Wildcat day.